Welcome everyone. It is once again a build day. As you can see by the title, today we are building an Av3 from IV-Works. This is an Arizu layout, split ergonomic keyboard, 65%, as all Arizu boards are. This one is from the round 1, as of recording this on July 11th, 2021. Forgot what date it was. There have been 3 rounds sold of this keyboard. I am unsure if there will be more. I will leave a link to the IV-Works website and Discord in the description. But this particular unit is number 69 from round 1. Nice. This is the certificate of authenticity that comes with each of the IV-Works boards. One of the many lovely little attention to detail things that Joe, the maker of this board, includes. So that's what we're going to be building today. That's the first thing you get in the front pocket is your authenticity card. You then get your hardware, which includes your bump-on feet, extra screws should you need them, and your Allen key. Now we will be using this one. Joe specifically mentioned in the build guide for this, that this being a stacked acrylic board as well, that this hex key will actually bend before you tighten the fastener so tight that it cracks the acrylic. So typically I like using my own hex keys, but he very specifically called that out, so we'll be using the included one. And then also being a stacked acrylic board with a stainless steel riser, this thing can be a fingerprint magnet during assembly. Joe has taken steps for post-assembly to make it less so, but for assembly he included a monogrammed microfiber cloth, which again, just one of those lovely attention to detail things that you will see about this keyboard. As we get into it, this was a case that was a free gift with round 1. I think this was included with round 2 as well, perhaps. But lovely form-fitting case. You can see the little scoop shape of the Arizu board. I've got my plate and PCB off frame here. All that's left in the case at the moment is the chassis of the keyboard itself. So you can see from the side profile here the stack construction of this board. Let's get that out of there. Just fantastic. So obviously paper and everything is still on, and you can see on the back here the already fingerprinted stainless steel, but that is why he includes microfiber cloth. So we will of course polish that up before we call it done for the day. So up this way I've got my computer screen with my notes, so if I pause and read something, I'll do my best to smooth that out in editing, but I am following along with the transcription of the build guide I made for myself. So first things first, we need to get all this paper off the acrylic. So we're going to bust out our hex key, Allen key, whatever your preferred nomenclature is here. So as we get this disassembled, today we're going to be using the R1 hot swap PCB, and we will be building with the palm plates today. I have never used a palm plate before, so I'm very excited to give that a try. For stabilizers, we'll be using Duroc V2 stabilizers that have had the Holy mod done to them. I just did those for the first time on my KBD 67 Lite, which I built just the other day, and it's fantastic. I may, if they go well on this keyboard, I may never do stabs any other way ever again, because the Holy mod is just fantastic. And then another first, for switches, we will be using my first Franken switch ever. We'll be using some Creamerons I built. So these are Kale Black stems, which are the same stems as found in the Novel Keys Cream switches. And then they are Gateron Milky Top Yellow housings. You can see my extra stems there. Milky Top Yellow housings and springs. They have Deskey's black switch films. Springs are lubed with Krytox 105, and the housings are lubed with Krytox 205. Krytox 205 grade 0. So should be a fun build today. A couple firsts. First palm plate for me, and first Franken switch as well. So these top 2 pieces are very similar. The top one is beveled slightly to give it a slight rounded edge. So we'll take these 2 and put these aside. These next two are also very similar. They have no cutout for the USB, but they do have cutouts for where the gaskets sit. So I call these the alignment layers. I believe Joe calls them the same thing. And then these last two layers are also the same. And these have the cutout for the USB-C ports. We'll be mindful to put these all back on in the same order because Arizu keyboards are slightly asymmetrical. So it's just something we'll keep an eye out for. And this is what I was talking about where there are different screw lengths involved. I'm not going to pick this up because it's just one piece of acrylic at this point, kind of flimsy. It's rock solid when it's all together. There's different screw lengths here holding these standoffs into place. So the whole bottom of the board actually comes assembled for you. There's nothing you need to do here, which is really nice. The superstructure, if you will, of the keyboard is all put together. So there's going to be a lot of paper peeling in this build, so I imagine I will be time-lapsing through a lot of that because it's not very interesting watching someone peel the paper off acrylic. Yeah, I'm going to go ahead and make with the peeling and the assembling. The first couple steps here involve actually just getting all the paper off of the acrylic pieces and getting the bottom 4 layers put back in position because they stay in place. And then we'll move over to our PCB, put that in place, and then put the 2 top layers back on. So let's begin. All right, well, there are the first 2 spacer layers. I'm calling these bottom 2 layers down. Really just more tedious peeling than anything, but man, this acrylic is crystal clear from the top and from the edges. So next up, I need to peel the alignment layers. And there we go with the 2 alignment layers of the keyboard. So at this point, that's pretty much actually the structure of the keyboard completed. Let me get some stuff out of the way here. Up out of the way. All right, next up is going to be peeling the top layers. Now the top layers are interesting because they are partially frosted. So what Joe recommends, this is the very top layer, so we'll set this aside. What Joe recommends is peeling the frosted side first, so there's no chance of you touching the glossy side while peeling it. So I think that's gonna be this side, based on how it was assembled in the packaging. It's harder to peel because obviously frosted. Yep, that's it. Oh man, oh, that looks so nice. That lovely frosted look. Goodness gracious. This takes slightly more force to peel because the way you frost something is by blasting its surface, which then generates on a microscopic level more surface area, so it grips on tighter. Also just could be as simple as the manufacturer uses a slightly stronger adhesive with frosted materials than glossy materials. So the main part to worry about with this is where it gets real thin here. The one thing you don't want to do is like dig in with your nail to catch an edge if you rip the paper, because you might damage the frosted coating. So just something to be careful with there, but we are successfully past that on this piece. So we're kind of in the home stretch for this one, and this is the second from the top layer. Still frosted though. And you can see as I go, I'm gripping the edges of the pieces of acrylic so that I don't leave marks on either of the faces, because the faces will be pinched between other pieces of acrylic, so you won't be able to like get in there and get rid of any finger marks without taking apart the keyboard, which is no fun. No one wants to do that. Whereas the edges are always visible, so you can easily go back and tidy any messes you make there with your fingerprints. I am not doing so good with this last little bit here. There we go. This is the frosty side. So the reason you want to do the frosty side first is because now, when you're working on the glossy side here, if anything, your hand is going to brush against the frosty side, which is much less fingerprint prone than the glossy side I'm about to peel is. Fantastic. I'm gonna lay that down. Oh my god, that looks so good. Even just the one frosted layer on top, that already looks absolutely fantastic. And then you can tell the top layer, because it is slightly smaller than the second to top layer, so it creates kind of a small bevel effect. So let's get our frosted side peeled on this one. I saw this corner was already up a little bit. There you go. That is all of the acrylic, at least peeled. And that is more or less what the final unit is going to look like. Just reading through my instructions here again. Yep, so now we're going to put in just a couple screws here to hold this together while we are prepping the internals of the keyboard. Okay, there we go, so there's that, just kind of locked together. In the meantime, next up are gaskets. So the way the mounting style for this keyboard works is, we'll just imagine that the PCB is on the underside here. This paper is the last bit of peeling we'll actually have to do. There are these wings off the edges of the plate that, if I can hold everything correctly, the foam aligns with. So on the bottom, the foam wings that line up with the plate rest on those alignment layers of the kind of cutaways, and I'll give a close up of that when we're doing it. And then on the top of the plate, you put these pour-on strips, so that you have the compression down and up to kind of hold everything in place. And then there's these huge relief cuts on this that make this a very bouncy keyboard, and doubly so with the pour-on, or the palm plate rather. So next up will be peeling the gaskets off of here, lining them up and getting them stuck onto the plate. And then one of the kind of benefits of this keyboard is, if like me, you purchased an extra plate and PCB kit, all you need to do is take the top 10 screws off. Those two top layers of acrylic, you can take this whole unit out and put in a different configuration with like a different plate, different switches, different caps, whatever. Because the mounting system lives entirely on the plate PCB combo, none of the mounting lives in the keyboard, if that makes sense. So pretty cool feature in my opinion. But let's get started mounting these strips. So each strip is sized to the position where it goes. We will start and just kind of go around. So generally speaking, the way Joe recommended this be done, let me just verify my sizes here, is peeling up your gasket strip, gripping it with a pair of tweezers, and then while it's in this kind of low adhesion scenario to your tweezers, line up roughly get one of the ends lined up. Let's kind of make sure the whole thing's roughly in the right place. And then get your tweezers out of there. And then use your finger to kind of make sure it's aligned with the outer boundary of the plate. Now, of course, he makes this look really easy because he's assembled a bajillion of these during testing. But what's nice is these pour-on strips peel back up pretty easily. So you can... There you go. Let me double sanity check myself here. This will go in that orient. Yep, and so this is the top. So an installed strip looks pretty much just like that. They're cut really, really precisely to length. There's the relief cut, and you just do that all the way around. So I will continue with that and catch you on the other side. Okay, so just about done with gaskets here. All of these, there's a very definitive space it goes in. You know, the gasket is as long as the wing, fin, whatever you like to call it, that's connected to. But these ones up front, there's quite a bit of material here. So with these gaskets specifically, you want to align with the outer edges of the material. Small note for those ones. Okay, so there we go. So that is our plate prepped at this point with all 7 gasket pieces in their appropriate places. So we can actually set this aside, and it is PCB time. PCB prep. Not a lot to do here actually, since we're using the hot swap PCB. We don't need to do any soldering today. All we need to do is actually mount our stabilizers. And test our stabilizers, of course. Whoops, and I am dropping stabilizers off my towel. For this one, as I mentioned, we are doing Duroc V2 stabilizers. I've got clear ones to match the clear acrylic of the Av3, so everything's nice and matchy-matchy. You need 5 2U stabilizers for this board. If you're using one of the solder PCBs, you can do split backspace. You only need 4 instead of 5. That being said, I'm doing hot swap. My other PCB is a solder one, so I may try that at some point. But for the moment, I will be doing full backspace. May do split at some point. So mounting stabilizers. Not going to show you all of them. It's pretty boring, but make sure you're all lubed up and ready to go. Again, these have the Holy Mod applied, so you can just see the Band-Aid inside the PCB through there, and then lubed with Krytox 205, grade 0. Mounting these is really easy. Anywhere a stabilizer should go, there will be those 4 holes. There's a pair of large holes and a pair of small holes. These small holes, you can see one side of the Duroc stabilizer screws in, this side clips in, this side screws in. The larger hole is where the clip goes. So you want to kind of insert that end of the stabilizer so that clip can get under the PCB, and you'll kind of feel it when it goes in. And then from there, they just kind of lay down, and that is it. Hard to focus on things edge on. Let's see if the camera will play nice. Nope, let's put my hand there. There you go. So you can see they're nice and flat against the PCB. Once you have all of your stabilizers in place like that, you flip it over, you screw them in with the included screws. Now, because of the way this PCB is made, you actually don't need the insulating washers. There is something to be said for the way the washers can make the stabilizers feel, so I will be including them, as most people do. But if for whatever reason the stabilizers you are using don't have those washers included, you're fine. It won't short out the PCB, in this case, the way this PCB is architected. So let me get those all mounted up. All right, so there's those just roughed into place. Now I'm gonna flip her on over and screw these in. As always, with every keyboard build, always test your PCB first. I already did that off screen, so I didn't bore you guys with that, because that's no fun to watch. Who wants to watch someone test a PCB? Always test your PCB first. Joe tested all of these before they went out. I trust Joe completely. Still tested it when I got it. Crazy things happen in shipping. PCBs can react strangely to things, so just check beforehand. There's nothing worse than building a keyboard and then discovering a whole column is dead or something. So just plug it in, use a pair of tweezers, test your PCBs. Okay, there are our stabilizers. Now, just like testing your PCB, test your frickin' stabilizers. Just test them. It doesn't take long. And you want to find out now if your stabilizers are tuned well, rather than finding out later, because that's no fun. So we're gonna pop switches in to all these locations. These insert very affirmatively. I like that. This is a very well-made PCB. Everything about this keyboard is well-made. I've been following this one for quite a while on the Discord, and this has been a very well thought out, very iterative product. Joe works in not manufacturing, but design of manufactured goods in his day job. So he was very familiar with a lot of that kind of stuff already, and got into keyboards like a lot of the rest of us did in mid-2020 because reasons, and was very open to taking feedback on everything from the website to the design and everything, and it really shows in the final product how well thought out all this is. I'm going to grab my keys for this. One moment. We're using GMK white on black for this keyboard. It was what the set was rendered with on the, or what the not what the set was rendered with, what the board was rendered with on the website leading up, and I really loved the way it looked. So we're going to be at least starting with that on my actual one. Moment of truth. Perhaps some very minor ticking on backspace. But if you're not familiar with the Holy mod and the way the Band-Aid is inserted, I'll leave a video link in the description to Homogeneo's guide on how to perform the Holy mod. Your stabilizers require some break-in because the way the Band-Aids work, I guess. So when you're testing stabilizers that have been Holy modded, do note that after some use they will actually sound a little different. And so I'm not terribly worried about the very minor ticking on that backspace key, because it very likely actually will break out. Break in, it will break out of that. That's actually, I'm not quite sure which one's correct there. After the break-in period, that might be fine. So I'm not terribly concerned about that, and otherwise those stabilizers sound fantastic. So we're gonna push forward here. no major ticking, no major binding. It's the kind of stuff we're looking for. So, fantastic. Next up, after doing all that, is prepping the plate foam. So we're gonna get the PCB out of the way for a moment now. Just stuff coming in and out of frame. So this foam is integral to the construction of the keyboard. And of course it's very see-through, so the camera's not interested in focusing on it. There we go. Is integral to the construction of the keyboard. This is not an optional plate foam because it acts as the bottom gasket for the assembly. So you absolutely need to have this. There's an option with this foam that is quite cool. You can see these cuts around the section where the alpha keys are. You can actually selectively remove the foam just from where the alpha keys are on this keyboard to change the sound, which is very cool. Now, one thing Joe recommends, however, is if you're using the palm plate like I am today, do not remove this because palm is so flexy. Having a void down below the alphas can actually cause too much flex because of how bouncy this keyboard is. So if you're using the palm plate as I am, do not remove this. If you're using the stainless steel or FR4, absolutely feel free to remove it to change the sound signature. And again, just one of these details, because the way this is kind of cut here, you can actually put the foam piece back in. So if you remove this and end up not liking the sound signature and want it to be a little more muted, don't throw out this piece of foam, because all you have to do is take the plate back off. Obviously on hot swap, if it's soldered, it's a bit more work. But with hot swap, you just need to pop this piece of foam back in place and it'll just sit in there. So very cool detail. I think it's a great option for tuning the sound of the keyboard. Because some of these points are so thin, this piece of foam actually ships with this piece of paper on the back. You don't have to remove it. Functionally, it doesn't do anything. If you don't, I'm gonna go ahead and do it just for sake of completeness. And you wanna be nice and slow with this because some points on this foam are like 0.6 millimeters wide. I think it's specifically like around here and around the stabilizers. The foam gets incredibly narrow. And if you rip the foam, technically that is also not a big deal because it's all getting sandwiched in between the plate and PCB. I would just still rather not, you know, just like to keep it all in one piece. I'm trying to find a corner here to get a hold on this paper. And it's not like the foam is adhesive under here or anything. It's literally just a protective piece for shipping to make sure it gets to you in one piece. Like this isn't tacky or anything at all on this underside. So it's not like you have to like stick this enormous piece of foam precisely anywhere. It is just for shipping. So I'm going to very slowly and carefully peel this off and I'll be back with you. So I did have one little tear here, just to show you that it is very possible to inadvertently do. So I'm gonna very slowly work that paper off. So you can see right there, again, around one of the stabilizer cutouts, that foam gets incredibly thin. And again, functionally that doesn't matter. So don't worry if that happens. And again, if you really just don't feel comfortable with it, you can leave this paper in place and it won't actually affect any of the functionality of the board. There is a chance you will see it through the side of the keyboard because the acrylic is so dang clear on this thing that you might see that little white edge against the black PCB, which I am not interested in doing, which is why I'm choosing to remove it. But just to show you, it's very possible it gets very thin in those sections. And don't worry if it happens to you. Just slowly, you know, get the paper removed from it and just keep on trucking down the keyboard. All right, and just here, actually where it's supposed to split to remove along the alphas right here. Hard to do that. There we go. Right there. Just split again. Again, totally okay. It's actually one of the places that is supposed to split to remove the alpha foam. So even less of a big deal. This is a really thin section by the spacebar cutouts here. You know what I actually might do is cut off the paper I have so far here in my hand, so that I'm not trying to manage this big wad of paper as I'm trying to get through this really fine section of the peel. That might be helpful. Who knows? Onward. I did rip in one more place, this very thin spot here, but again, functionally, it doesn't matter. So there you go. There's your liberated plate foam, mounting foam. Not sure what the most accurate name is there. And now we get to do the business end of the deal here and actually make the part of the keyboard that's the keyboard. So we're gonna get our PCB. We're gonna throw our foam over top. I'm gonna look for the sections that I ripped. Make sure they're not gonna be intrusive on anything. One's right here, which is by a stabilizer wire, which is like a little concerning, but it's probably fine. There's the alpha I ripped, it's staying nicely in place. This one, of course, also by a stabilizer wire. So hopefully those don't get like tangled in each other. I actually can't imagine that would be the case because the foam is gonna be compressed in here. So you got your PCB, you got your prepped foam. Again, this would be the time to remove the alpha cluster if you're going to. Palm plate, you don't wanna do that. It's gonna be way too flexy and may cause issues. And then you wanna get your plate in place over top. So you kind of want to get things roughly aligned here. That's pretty close. And then as with all keyboard plates, what you want to do is you want to get your corners taken care of first. Because what that's going to do is it's going to lock the plate in place. So you want to pick two corners where you have 1U slots. In this keyboard, it's all of them. So it doesn't really matter which corners you go with. But once you get those corners done, it locks it in position. It is now rotated correctly and it's aligned in both directions correctly because the way physical constraints work. So there you go. From here on, I'm going to pop in the rest of the switches, quick test the keyboard again off screen as not to bore you with that, and then we will continue with assembly. All right, so all switches inserted and tested. We tested out perfectly, which is fantastic. Love, love, love hot swap boards. Yeah, God, this thing's beautiful inside and out. All right, cool. So now we need to get this into this. So here. Get our hex key. Pull these screws back out. I didn't move my board very far while I was assembling the PCB, so probably didn't need to do that part. But if you're going to be putting this on a different table or something while you're putting together your PCB, if you don't have enough workspace, you definitely want to at least put those 4 screws in to hold this thing together while you move it. It is very structurally reliant upon the screws being in. It's kind of like the SR-71 Blackbird in that way. Leaks fuel on the tarmac, but then at altitude, looks amazing. So we're gonna get those 2 top layers out of the way, again, grabbing them by the edges. And I'm gonna quick read my notes here again. Yep, so from here we're just doing putting this in and screwing things together. So you can see here, The USB port sticks down. Camera stuff. Trying to do this and look at my monitor. There, there we go. All right, so you can see the USB port just sticks down off the edge there. And that's really the most important part to get aligned first. So you kind of want to put this thing in like top first and lay it down. Oh, it's now you can see, like I was talking about earlier, those pockets. So it's clear acrylic, so it's hard to see, but you can clearly see the shadows where those cutouts are, and they align with these wings. So these wings go into those pockets. On the bottom side, the foam that actually goes all the way through the PCB assembly rests on the case via gravity. And then on the upstroke and some compression force comes from this pour-on when you screw on the top layers. So that's kind of how this all fits together. So there's that dropped into place. That goes in super easily, actually. What Joe recommends is pushing it up hard against the top edge, and then just, there's intentionally a little bit of engineered play in here, because you don't want the plate or PCB to be touching the case anywhere, or the acoustic force will transfer through. So what Joe recommends is pushing it hard against the top edge, and you guys are just getting hair cam, aren't you? I moved the camera this way compared to my last video, so it's looking back towards, and that has helped some, but sorry about that. You want to push it hard against the top, and we'll fix that in a moment, and then use that to align it left to right. And if you might be able to see that in the video. I can probably zoom in and post a little bit. You can see where it's kind of centered, and that is about right there for me. So now, because we've touched this upper edge of this a whole bunch, we want to give that a quick wipe down so we're not trapping fingerprints between the layers of acrylic. And you can really just see how crystal freaking clear that acrylic is. That's pretty nuts. And I nudged it a little bit, so I'm gonna just make sure we're still aligned left to right and registered against the top. As we are, that's fantastic. God, that looks good. And now we should be fingerprint free on these because I haven't touched them. This would be the time to wipe these down if you're gonna. Place that on. I'm gonna lift up just this top layer, check its underside real quick. This is the upside of building keyboards under filming lights, is that it's actually very easy to see blemishes because of the reflection of the very bright light I record under. And this isn't like world ending if you trap anything here. You can always take it back apart and re-clean anything. But if you want to get it right on the first time, now's the time. And oh my gosh, that looks so cool. Just seeing the gaskets subtly through the top and then the white palm plate. I'm really excited to build this again later with the FR4 plate, so you'll kind of see the black solder mask on the FR4 through the top frostage. Looks so good. Looks utterly fantastic. And now comes tightening these screws. So there's a best order Joe has figured out to tighten these in. So starting with the upper left corner, which is this one here, get this one in just lightly. So like I'm going till I just feel a little bit of feedback, and then I'm backing off just a hair. Just feeling some feedback, backing it off just a little. Just a feedback and backing off a little bit. So now you've got very lightly tightened corners. And so now remember how it's centered left to right. You can kind of look in and check that again. And now that you got it this far, pull it down away from the top just a hair. So now at this point, just tugging down on it a little bit. At no point should the plate or PCB be in physical contact with the rest of the case. All the mechanical interface at this point is either through that lower foam or through the upper foam. Pretty snappy. And the reason you want to do that now is because as you tighten down the screws, it's going to compress everything into place. So you want to get everything centered up now. And again, of course, you can always loosen it and come back later. You just want to get as close as possible right now. So fantastic. There we go. So now we want to get these finger tight. So using the short, I've got the long end of the hex key actually in the screw, and I'm tightening using my fingers on the short end because that's going to limit how much torque you can put on. You kind of want to go around clockwise just till those are finger tight. Drop your hex key for good luck, as is required. So kind of check and make sure everything feels square, which it does on mine. Fantastic. Now next up are the center screws. The side screws don't actually hold any compressive force. All the side screws are doing are holding the first layer of the stainless steel riser on the back. So we'll do these last. So next up, we'll get these center screws done. Same deal. Gonna kind of hold everything, make sure it feels nice and square. Tighten this down until it's, again, just finger tight using that short end for leverage so you're not over tightening anything. And we're gonna zigzag across over to this one. Just like that. So at this point, everything should feel pretty squared up, pretty tight. And so now we want to do our edge screws. Again, just finger tight using the short end for leverage so you don't over tighten. Probably sound like a broken record, but that's super important. So now the board is a, oh my God, very heavy, complete and solid board. And you kind of get your first look at it, picking it up. You can see just how crystal clear that acrylic is to the sides. You can see the FR4 layer there, the PCB, the black foam, and the plate. Really, really beautiful. And so now you want to just do the final tightening of these. And with acrylic boards, stacked acrylic boards, you need to be careful not to crack the acrylic by tightening them too tight. So what Joe recommends, once you have these kind of finger tight, is putting the hex key in now with the long lever arm here, and depending on your frame of reference, what's easier for you to kind of visualize, either turning it another 60 degrees or 2 hours on the clock. Now I wear a digital watch, so that's not going to work, but either 60 degrees turn or about 2 hours on the watch face. Right there. And so you can see how my tool was actually bending there. You're good. Don't go too much past that. And for this phase, you want to start with this screw, go every other screw around the edge of the case doing that. Yep, there's my hex key bending. Perfect. There's my hex key bending. There's my hex key bending. There's my hex key bending. Okay, so now we've done every other. So now you want to restart that process with the far upper left screw. There's my hex key bending. Hex key bending. Hex key bending. Hex key bending. And hex key bending. And there you go. So that is more or less proper tension across this board. Not the most scientific, but I know Joe did a whole ton of testing when assembling these. This is called the Av3 because this is the third major version of this keyboard. Not counting all the minor versions and revisions he did before getting to the shipping version. motion. So really fantastic. Then last is putting on the bump on feet. I'm gonna put something soft under it because that requires flipping the keyboard over. So we're gonna get her flipped upside down here. I'm gonna try and get some of these off. Best way to clean this is spraying isopropyl alcohol onto the cloth and then wiping the stainless steel riser down. The isopropyl alcohol will not rust the stainless steel. Do not use the isopropyl alcohol on the acrylic as it may not react favorably to that. But fortunately with these fingerprints, it looks like just a little love with the cloth did the job. So, feets. They are technically optional. You can see the reflection on my hand from the stainless. That reflection's coming from my window behind me. I meant on the palm of my hand. The feets are technically optional. However, it is very possible that if you're using this keyboard on a hard surface, that it would scratch the steel. Or if there is something under your keyboard, that the keyboard will scratch what's under it, again, because of the stainless steel. So I'm gonna put the feets on just to be safe. It comes with 7, you actually only need 5. The recommended placement of these is one right here to support this corner. Mirroring that on the other side, dropping the foot first for good luck. And just kind of check them before you press the second one in, make sure they are more or less aligned, which they appear to be. Get them pressed in nice and firmly. So now those are the bottom two. So now because this case is terraced like this, you are not gonna put the feet where you think you would for this upper layer. You wanna follow this foot straight up to get your left to right alignment, and then don't drop the footy in. And then you wanna place the foot actually pretty close to this leading edge of this top piece of stainless steel. If you put it here, this edge of the steel will actually contact the desk before the foot will. So you want it the center of this foot about 1/3 of the way up the stainless steel. And you just lightly drop it in place. Check your alignment. See if that looks good. That looks pretty darn good. And then press it in place. And then do the same thing on this end. Once again, checking this alignment and this alignment to make sure they are square-ish with each other. Obviously they will be on the bottom, but if you're someone like me, you will know if they are not quite right looking. Fantastic. And then if the feet are optional, this foot is really optional. This one goes kind of on the bend here of the board. The way you figure out this one is you want to use the center of this beak, I guess. Beak, whatever you want to call it. This protrusion on the bottom of the board. What you want to do is kind of follow the line between these. And that line through the center of these 2 feet is where the top edge of this last bump on should go, and then centered with the beak. I will show you again once I have it on here in a moment in case that wasn't completely clear. That's gonna be pretty darn close. So what I meant was, if you draw a line from this foot to this foot through the center, that line is where the top edge of this foot should go. And then, so that sets the vertical height of the foot. And then the left to right should be more or less centered with this little beak here, as I have more or less achieved. Give these one more wipe down. I will need to give this a more thorough cleaning or calling it actually good, but that is pretty darn good. Lift it up, oh my God. This thing weighs a ton. And there you are. That is, except for caps, a finished Av3 keyboard by IV-Works. That is a very handsome board, especially with those black and white Creamerons. That looks awesome. So, caps. We're gonna be doing GMK white on black, as I mentioned, because that's what was, oh my God, that is flexy. Holy moly. I'm not sure if you can see that on camera. I will try and zoom in if I can. This is a very, very bouncy board. That's awesome. I believe this shift key fits in right there. Backspace. I want to say this shift goes here. Look at me go. This shift goes here. Nope, that is not the right size shift. I need a slightly shorter shift to get there. Pop that back in. Cool. Well, let me grab my white on black keycaps. Okay, there we actually go. Goodness gracious. Look at that keyboard. That looks absolutely fantastic. Absolutely fantastic. The frosted acrylic finish is so nice. Oh, it rests just like perfectly on those feet. Goodness gracious, Joe. All right, well, there you go, everyone. As usual, I will append some sound tests to the end of this. Give you a little teaser right now. Very, very poppy and deep with the Creamerons on that palm plate. I won't go into Creamerons right now. I will link a video below that Shubes made about cream-based Franken switches and using kale black or red stems instead of actual cream stems. And he just, in general, talks about cream-based Franken switches in some detail in that video, specifically looking at using the kale stems from other switches as an alternative. So that will explain why Creamerons are favorable. Long story short, the stem has a slightly different geometry that changes the bottom out sound and feel, and I am absolutely feeling that. So I'm going to remember how to type on Alice Arizu style layouts, and I will append a typing test at the end. Thanks so much for hanging out with me today while I build Av3 number 69 from R1 from IV-Works. If you enjoyed this, drop a like on the video. If you want to see more like it, hit subscribe. And if you got any questions, please leave a comment. I love talking to everyone who watches my videos, and I love answering questions as well. So you know where to find me. Enjoy the sound tests, and I'll see you next time.